question 10 asks which of the one of the following experimental conditions will change the actual value of K. All right. A, we increase the concentration of the product. B, we increase the concentration of a reactant. C, we increase the pressure. Or D, we decrease the temperature. Now, whenever you change the concentration of something, there is going to be a shift, but don't confuse a shift with a change in the actual K value. All right, we've seen that before again with ice tables. I'll just use simple letters here to avoid confusion. If initially we have 0 and 0 and 5, yes, the reaction shifts to the left, but the K for the equilibrium is the value for all the equilibrium, okay? No matter what the concentrations are, the equilibrium constant is a constant, okay? If we increase the pressure, Kc, all right, or the equilibrium constant, which is, can be related in terms of the value of Kc, is also a constant, okay? This is the same thing as increasing the concentration of something if we change the pressures. Now, if you decrease the temperature, that actually is going to change the equilibrium constant because the equilibrium constant is a function of the free energy of the system, as we'll see later and we've talked about later, okay? So, temperature affects the equilibrium constant, okay? We don't need to plug anything in, but I just thought I would show it in here. Delta G over RT. So if we change the temperature, we change the equilibrium constant. Okay, so that's the only way to change the equilibrium constant, by changing the temperature. And that's why most equilibrium problems and so on tell you what the temperature is. For example, 100 degrees Celsius or something like that. Okay, because they want you to know that that equilibrium constant is constant, and it's valid only at 100 degrees Celsius. At 200 degrees Celsius, it's going to be a completely different answer.